Section 9.2 is about adding and subtracting rational expressions. If you're going to add two fractions together, you have to get common denominators. And if you're going to add or subtract rational expressions, you have to do the same thing. To do that, we have to talk about this idea of LCM, or least common multiple. That's the smallest factor that both of the numbers or expressions will go into. To find the least common multiple, you find each factor the greatest number of times that it appears. So we're going to show you how to do that here in these two examples. If I want the least common multiple of 6 and 4, I'm going to take the number 6 and I'm going to break it into 2 times 3. Those are the factors that make it up. Likewise, I'm going to take the number 4 and break it up into 2 times 2, because those are the factors that create it. Now, according to the LCM, I want to find each factor the greatest number of times that it appears. Here the number 2 appears one time, but here the number 2 appears twice. So I'm going to take 2 2's, because there's more 2's in the second one than there is in the first one. There's also a factor of 3. In the top one it appears once, but in the bottom it appears twice. So I'm going to take a 3 also. So 2 times 2 times 3 is 12. Therefore, the least common multiple between 6 and 4 is 12. Over here, to find factors of trinomials, I have to use methods that we've learned about in the past, in this case the diamond. So two factors of 9 that add to be -6 are a minus 3 and a minus 3. And then this one over here, a plus 4 and a minus 3. Now I'm going to take each factor, the maximum number of times that it appears in each one of these rows. So it looks like I'm going to take a minus 3 twice, because the top one has 2 of them, and then the bottom has an a plus 4. So this is the least common multiple of these two polynomials. Here we're asked to find the least common multiple of 3 monomials. Some people like to use factor trees to do that, to find what the prime factorization is. So you see an example of a factor tree here. So if I break up 18 into 2 times 3 times 3, and then use the 2 r's and the 5 s's, it helps me see all the factors. Now I'll do the same to 24. So 2 times 2 times 2 times 3, and then the r's, s's, and t's. And then the 15, 3 times 5. So we break this one up also. Now, to find the least common multiple, we want to take every factor the maximum number of times that it appears. There's 1 2, 3 2's, and no 2's, so we're going to take 3 of them. There's 2 s's, or 2 3's, 1 3, and no 3, so we'll take 2 of the 3's. There's a single 5 here, so we'll take that. It looks like 3 r's are the maximum number of r's. 5 s's. And 2 t's. So if we put all of this together, my least common multiple is 360 r to the third, s to the fifth, t squared. That means each of these monomials is a factor of that monomial. Here we're going to find the least common multiple again, but this time with polynomials, so factoring them will be a little different. This first one I'm going to take a p out, and then this trinomial can be factored using the diamond. P plus 3 and P plus 2. So there's that one. Over here, I can just use the diamond. P plus 3 times P plus 3. So now I have this one and this one. If I take every factor, the maximum number of times, I'm going to take 1P. I don't have to write the dot. So 2P plus 3's and 1P plus 2. You can also write that by using a square on the P plus 3's. Either one of these answers is acceptable. In this example, we're asked to add two fractions. Now, to do that, we have to get common denominators, and that's been the purpose of us finding the least common multiple, is we use the same procedure to find the least common denominator. So we want to find the smallest denominator that both of these are factors of, and we're going to call that the least common denominator. Now, I'm not going to take the time to write out all the work to find the denominator here. I'll let you do that. We've done it enough so far to practice. I'm just going to tell you that the common denominator here is 90xy squared. So we want 90xy squareds to show up on the bottom. The question is, how do we get that? Well, we're going to have to multiply by some form of 1 on both of these fractions. So what can we multiply 15 by to get a 90? And that would be a 6. But then we also are missing the x. So we're going to multiply the top and the bottom both by 6x. Likewise over here, 18 times 5 gives me 90, but I'm missing one of the y's. So I'm going to multiply by 5y, and that's going to allow me to get 90xy squareds all on the bottom. Top over here will be a 42x squared over 90xy squared. Here we'll get 5y squared, again over 90xy squared. You cannot add or subtract fractions unless you have those common denominators. So now that we have it, I'll put the tops together, and that'll all be over my common denominator of 90xy squared. Now, if there's any kind of factoring I could do on the top or bottom, I'd want to do that and cancel. But I can't cancel anything here because this is a binomial and this is a monomial, and you can't take pieces of it. You have to take factors. So this is how my expression would simplify. Here you have a subtraction problem, and it's a lot easier if we factor the numerator and denominator. So I'm going to take a 4 out of the bottom here. It's a lot easier to see what the factors are if you do that. And then I can take a 2 out of this denominator. And so now my least common denominator is every factor the maximum number of times that it appears. So I'm going to need that 4. And since 2 is in 4, then that's all I need is 4, and I only need one of the w minus 4. So there's my least common denominator. So the only thing that really needs to be fixed is this one. It's missing a 2 because 2 times 2 would give me the 4 that I'm looking for. So I'll rewrite these. So by taking the 2 and distributing it to the w plus 4, I get 2w plus 8. 2 times 2 gives me 4. Now if I'm going to combine these together, one thing that students often forget about is when you're subtracting the 2w minus 8, you're really subtracting both. So in a sense, you're distributing that subtraction sign. So we'll make this minus 2w minus 8 over the common denominator of 4 times w minus 4. Simplifying on the top, negative w plus 4. And now, if you recognize, I could take a negative 1 out of that top one and make it positive w minus 4, which will cancel with the w minus 4 that I have on the bottom, leaving me a final simplified solution of negative 1 over 4. In this problem, we have a complex fraction, so we have division of two rational expressions. I'm going to rewrite it this way, in a sense breaking it all up so we can deal with each one separate. So over here we're looking for a common denominator, an LCD of xy, because that would take both factors into account. So I'm going to multiply this left side by y over y, because that's the missing piece, and this side by x over x. So we're going to get y over xy minus x over xy, and now put the whole thing together, y minus x over xy. So that's simplifying the numerator. Now I'll go over here and simplify the denominator. I'm going to turn 1 into 1 over 1. The LCD needed over here looks like just an x. So I'm going to multiply by x over x to get that. So we'll have x over x plus 1 over x, and then putting them together, we get x plus 1 over x. So now that I've used common denominators to put the numerator and the denominator together, now I'm going to use multiplication of the reciprocal to turn this into a multiplication problem. So I'll flip the second one and see if anything cancels. Well, I have an x factor here and an x that's a factor here, and I believe that's it. So on top I'm going to have y minus x. On the bottom I'm going to have y times x plus 1. Now you could rewrite that as y minus x over xy plus y by distributing the y. Either one of these is acceptable.